In this video, we're going to look at an example of what we have to do if both the powers on sine and cosine are even for a trigonometric integral. So we've got the integral from 0 to pi of sine squared t cosine to the fourth t dt. So unfortunately, we can't peel off one copy of sine or one copy of cosine and convert the rest to sines or cosines because I have an even power, and that if I peel one copy of sine off or one copy of cosine off, that leaves me an odd power of either sine or cosine. And that doesn't help me using the trig identity sine squared plus cosine squared equals 1 to change one into the other. So we have to use what we typically refer to as the power reducing formulas or the half angle formulas. We have both of those names. We can replace sine squared t with 1 minus cosine 2t over 2. We can replace cosine squared t with 1 plus cosine 2t over 2. And rewrite cosine to the fourth t as cosine squared squared, and that's where this extra squared comes from. So if you go through all the algebra and multiply all this out, you'll get a 1/8 for your constant. You can move it out in front. You'll get a 1 plus cosine 2t minus cosine squared 2t minus cosine cubed 2t dt. We can integrate 1, no sweat. Integrate cosine 2t, no sweat. Integrate cosine cubed of 2t, little sweat. We can pull off one copy for your du and convert the rest of the cosines to sines. So this last term we can write as 1 minus sine squared 2t times cosine 2t. And so we can do that with a u substitution. The middle piece is the part that we're going to have an issue with, because they have another even power of cosine. So we have to use that power reducing formula again by replacing this with 1 plus cosine of 4t over 2. Remember, using our power reducing formula, the argument on the cosine gets doubled. So we started with 2t, it goes up to 4t. Just playing around and simplifying some things. This is a minus 1/2, so it makes the constant a positive 1/2, and then we get a minus 1/2 cosine 4t. So that's where that term's coming from. It's just doing some housekeeping here on the previous term. All right. We can do the antiderivatives here individually. I know an antiderivative of 1/2 is just 1/2 t. I know an antiderivative for cosine 2t is a 1/2 sine 2t. For minus 1/2 cosine 4t, you'll get a minus 1/8 sine 4t. This last piece here, we need to do u substitution. That's what I've done over to the side here. Let u equal sine of 2t. du is 2 cosine 2t dt. We'll need to adjust for a 1/2 out in front for your du. Do your u substitution. Take an antiderivative. Substitute back in. That antiderivative for that last piece in our integral is 1/2 sine 2t minus sine cubed of 2t plus c. This problem now was asking us to do a definite integral, so I need to plug in the endpoints 0 and pi. Well, notice that if you plug in either 0 or pi into sine of 2t or sine of 4t, you're going to get 0. So the only thing that's going to survive is the 1/2 pi. It's also being multiplied by the 1/8, so you get a final answer here for our definite integral of pi over 16.